Every star you see in the night sky, every shimmering point of light, has its own extraordinary origin story. They aren't just born, they emerge from some of the most mysterious and powerful places in the universe, stellar nurseries. These cosmic cradles, vast clouds of gas and dust, are where the magic of star formation begins. But what exactly happens in these nurseries? How do these colossal clouds give birth to stars that will burn for billions of years? And why are they so crucial to the story of the universe itself? Today, we're diving deep into the heart of these stellar nurseries to uncover 10 fascinating facts about how stars are born. From the incredible forces at play to the mind-boggling scale of these cosmic factories, you're about to discover why stellar nurseries are not just essential to the universe, they're also one of the most awe-inspiring phenomena in existence. So let's journey together into the heart of these celestial wonders and explore the secrets of how stars come to life, ready to uncover the mysteries of the cosmos. Let's begin. Picture this, a colossal, swirling cloud of gas and dust stretching light years across the vast emptiness of space. This isn't just any cloud, it's a stellar nursery, a cosmic cradle where stars are born. Think of it as the universe's own maternity ward, where raw materials come together to ignite the brilliant lights that dot our night sky. These nurseries are made up mostly of hydrogen and helium, the simplest and most abundant elements in the cosmos, along with traces of heavier elements forged in the hearts of long-dead stars. But these clouds are far from peaceful. Within their depths, gravity works tirelessly, pulling particles closer and closer until the pressure and heat become so intense that nuclear fusion ignites. This is the moment a star is born, bursting into life and illuminating the darkness. Stellar nurseries aren't just a backdrop for star formation, they're the very foundation of it. Without them, galaxies would remain dark, empty voids, devoid of the energy and light that stars provide. Scientists often describe these nurseries as the engines of cosmic evolution. Dr. Emily Levesque, an astrophysicist specializing in star formation, once said, "Stellar nurseries are where the universe writes its next chapter," and she's right. Every star, from the smallest red dwarf to the most massive blue giant, begins its journey in one of these incredible regions. They're not just important, they're essential to the universe as we know it. But what happens inside these nurseries? What forces and processes come together to transform a cloud of gas into a blazing star? The answers lie in the intricate dance of gravity, pressure, and cosmic chemistry, a story we'll dive into next. Now, let's break down what makes up these stellar nurseries, the cosmic kitchens where stars are born. At their core, these nurseries are made up of vast molecular clouds, enormous collections of gas and dust drifting through the galaxy. Think of these clouds as the raw ingredients for star formation, like flour, eggs, and sugar waiting to be mixed into something extraordinary. But instead of baking a cake, we're talking about creating stars. Trillions of tons of gas and dust swirling together in a delicate dance. What holds all this material together? The answer is gravity. Imagine gravity as the cosmic chef, pulling these gas particles closer and closer, compressing them into denser clumps. Over time, these clumps grow heavier and hotter, setting the stage for something incredible to happen. But gravity doesn't work alone. Temperature, density, and pressure are the other key players in this recipe. As the gas and dust compress, the temperature rises, creating the perfect conditions for star formation. Density increases as more material gets packed into a smaller space, and pressure builds, pushing the particles to collide and interact. It's a delicate balancing act. Too much heat or pressure, and the process stalls. Too little, and the cloud remains a loose, drifting mass. To put it in simpler terms, think of a pot of water on the stove. As you turn up the heat, the water molecules move faster and faster, eventually reaching a boiling point. In stellar nurseries, the heat comes from gravity's relentless pull, and the boiling point is when a star ignites. This process doesn't happen overnight. It can take millions of years for these ingredients to come together just right. But when they do, the result is nothing short of spectacular. And speaking of spectacular, this is just the beginning. Once these ingredients are in place, the real magic starts to unfold. In the next section, we'll explore how these clouds of gas and dust transform into the glowing, fiery stars that light up our universe. Stay tuned, it's about to get even more fascinating. Gravity is the quiet architect of the cosmos, shaping the chaos of gas and dust into the brilliant stars that light up our universe. Picture a vast, empty space filled with swirling clouds of hydrogen and dust. These clouds might seem lifeless at first, but gravity is always at work, pulling particles together bit by bit. Over time, these tiny particles begin to clump, forming denser regions within the cloud. It's like watching a snowball roll down a hill. It starts small, but as it gathers more snow, it grows larger and heavier, accelerating as it goes. In the same way, gravity pulls gas and dust together, creating denser and denser clumps. As these clumps grow, their gravitational pull becomes stronger, drawing in even more material. This process, known as gravitational collapse, is the first step in the birth of a star. But it's not just about gathering material, it's also about heat. As the clump contracts, the particles within it collide more frequently, generating intense heat. Over millions of years, this heat builds up, turning what was once a cold, diffuse cloud into a hot, dense core. And here's where things get truly fascinating. This dense core is the birthplace of what we call a protostar, the very first stage of a star's life. But we'll dive deeper into that in just a moment. For now, think of gravity as the invisible hand that sets the stage for one of the most spectacular events in the universe, the creation of a star. It's a process that's both incredibly slow and unimaginably powerful, a reminder of the forces that shape the cosmos on scales we can barely comprehend. Deep within the swirling chaos of a stellar nursery, where gas and dust dance in the darkness, something extraordinary begins to take shape. This is where protostars, the very first stage of a star's life, are born. Picture a dense cloud of gas and dust slowly collapsing under its own gravity. As it contracts, it heats up, forming a glowing core, but this isn't yet a star as we know it. At this point, it's a protostar, a young, celestial object still gathering its strength, not yet hot enough to ignite the nuclear fusion that powers mature stars. So, how does a protostar grow? The answer lies in the accretion process. Imagine a cosmic whirlpool where the protostar sits at the center, pulling in material from the surrounding disk of gas and dust. This isn't just a slow trickle, it's a violent, chaotic process with jets of material shooting out from the poles of the protostar as it feeds. Over thousands of years or even longer, the protostar accumulates enough mass to begin its transformation. Recent observations by telescopes like the James Webb Space Telescope have given us stunning glimpses of these cosmic cradles. For instance, in the Orion Nebula, astronomers have spotted protostars surrounded by glowing disks of material, their brilliant jets cutting through the darkness like cosmic flares. These observations not only confirm our theories but also bring the process to life, showing us the raw, dynamic energy of star formation in action. As the protostar continues to grow, it inches closer to the moment when its core will ignite, marking the birth of a true star. But what happens next? How does this young, fiery object evolve into a full-fledged star? That's where the story takes an even more fascinating turn. Deep within the swirling chaos of a stellar nursery, something extraordinary happens. Picture this: a protostar, once a dense cloud of gas and dust, has been collapsing under its own gravity for thousands, even millions of years. Now, its core is reaching unimaginable temperatures, millions of degrees Celsius. At this critical moment, the pressure and heat become so intense that hydrogen atoms, which have been bouncing around like tiny particles in a cosmic dance, finally collide with enough force to fuse together. This is the moment of ignition, the birth of a star. When hydrogen atoms fuse, they form helium, releasing a staggering amount of energy in the process. This energy is what powers stars and makes them shine so brilliantly. It's like lighting a cosmic fire that will burn for billions of years. The energy radiating outward from the core counteracts the relentless pull of gravity, creating a delicate balance that allows the star to stabilize and enter the main sequence phase of its life. This is the moment a protostar becomes a true star, joining the countless others that light up our universe. The physics behind this process is both simple and profound. Fusion occurs because the extreme conditions in the core strip electrons from atoms, turning the gas into a plasma. In this state, atomic nuclei can overcome their natural repulsion and merge. The energy released isn't just light and heat. It's the very force that shapes galaxies, drives planetary systems, and ultimately makes life possible. It's a reminder of how interconnected the universe truly is. Now, imagine standing in the heart of a stellar nursery, witnessing this cosmic event. The birth of a star isn't just a scientific phenomenon, it's a breathtaking transformation, a moment where raw potential becomes radiant reality. But not all stars are born the same. Depending on the conditions in their stellar nurseries, they can grow into vastly different kinds of stars, each with its own story to tell. And that's what we'll explore next: the dazzling diversity of stars that emerge from these cosmic cradles. Stellar nurseries are like cosmic factories, but instead of producing identical products, they create an astonishing variety of stars. From the smallest, dimmest red dwarfs to the brightest, most massive blue giants, these nurseries are responsible for the incredible diversity we see in the night sky. But what exactly determines whether a star becomes a small, cool red dwarf or a blazing hot blue giant? The answer lies in the amount of material available when a star forms. When a dense cloud of gas and dust collapses under gravity, the mass of the material it gathers plays a crucial role in shaping the star's future. A smaller clump of material might form a red dwarf, a star that burns slowly and steadily for trillions of years. These stars are the most common in the universe, and while they may not shine as brightly as others, their longevity makes them fascinating. On the other end of the spectrum, if a star gathers an enormous amount of material, it becomes a blue giant. These stars are incredibly hot, luminous, and massive, but they burn through their fuel much faster, living only a few million years before meeting dramatic ends. Take, for example, the star Rigel in the constellation Orion. It's a blue supergiant shining with an intensity that dwarfs our Sun. In contrast, Proxima Centauri, the closest star to our solar system, is a red dwarf so faint that it's invisible to the naked eye. These extremes highlight the incredible range of stellar possibilities born from the same stellar nurseries, but it's not just about size and brightness. The temperature and color of a star are also determined by its mass. Smaller stars like red dwarfs have cooler surfaces, giving them their reddish hue. Massive stars like blue giants burn so hot that they emit a brilliant blue-white light. And then there's everything in between, like our Sun, a yellow dwarf that sits comfortably in the middle of this stellar spectrum. The lifespan of a star is another key factor shaped by its mass. Smaller stars may live for trillions of years, while massive stars burn out in just a few million. This stark difference is a reminder of how varied the universe truly is. And when we look at the stars in the night sky, we're seeing the results of these processes, each one a unique product of its stellar nursery. As we marvel at this diversity, it's worth noting that stars often don't form alone. They are frequently born in groups bound together by gravity, forming what we call star clusters. These clusters are like cosmic families, and they offer a fascinating glimpse into the shared origins of stars. But that's a story for the next section. Now let's zoom in on the cosmic neighborhoods where stars are born: star clusters. These are essentially families of stars bound together by gravity and often forming from the same stellar nursery. Picture a bustling city of stars all sharing the same origin story, but not all star clusters are the same. In fact, they come in two main types: open clusters and globular clusters. Open clusters are like the younger, more dynamic members of the stellar family. They're loose, irregular groups of stars, often containing a few dozen to a few thousand members. The Pleiades, also known as the Seven Sisters, is a famous example you can spot with the naked eye in the night sky. These clusters are relatively young, with stars that are still bright and hot, born from the same cloud of gas and dust. Over time, though, the gravitational bonds that hold them together weaken, and they gradually drift apart. On the other hand, globular clusters are the ancient, tightly knit cousins of open clusters. These are massive, spherical collections of hundreds of thousands, or even millions of stars packed closely together. Think of them as cosmic beehives buzzing with activity. A well-known example is the Hercules cluster, which contains stars that are billions of years old. These clusters are like time capsules, offering a glimpse into the early universe and helping astronomers piece together the history of stellar evolution. But why are star clusters so important? They're like cosmic laboratories, giving us a front row seat to how stars evolve. By studying the different types of stars within a cluster, some aging, some exploding, and others just starting to shine, we can piece together the life cycle of stars. It's like watching a family album come to life, with each star telling its own story. As we marvel at these stellar families, it's worth noting that the environment within a cluster isn't static. Stars interact, collide, and even influence each other's evolution. And speaking of influence, there's another force at play that shapes the destiny of these clusters and the nurseries they come from: stellar winds. But we'll dive into that cosmic phenomenon in just a moment. Stellar winds are like the cosmic breath of young stars, powerful and relentless. As these newly born stars ignite and begin to burn, they don't just sit idly in the void. They unleash torrents of energy in the form of stellar winds. These winds, made up of charged particles racing outward at incredible speeds, act as sculptors, carving and reshaping the gas and dust clouds around them. They can compress nearby material, creating dense pockets that might collapse under their own gravity and spark the birth of even more stars. But they can also do the opposite, blowing away the very clouds that birthed them, dispersing the raw materials needed for future star formation. Take the Orion Nebula, for example. Here, the intense stellar winds from massive young stars have created a dynamic environment. They've not only shaped the nebula into its iconic structure, but also triggered the formation of new stars in the surrounding regions. Similarly, recent observations from the James Webb Space Telescope have revealed how stellar winds from infant stars in the Carina Nebula are pushing against dense gas clouds, creating shockwaves that ripple through the cosmos and influence the evolution of entire star clusters. But stellar winds aren't just about creation, they're also about transformation. Over time, these winds can erode the surrounding material, dispersing it into space and leaving behind a clearer view of the young stars at the heart of it all. This interplay between creation and dispersal is a delicate dance, one that shapes the life cycle of galaxies. As we marvel at the power of stellar winds, it's worth noting that they're just one chapter in the story of cosmic forces. Next, we'll explore an event even more explosive and transformative: supernova, the dramatic final acts of massive stars that scatter the seeds of future stars across the universe. When a massive star reaches the end of its life, it doesn't fade quietly into the cosmic background. Instead, it goes out with a bang, a supernova. These colossal explosions are some of the most powerful events in the universe, releasing more energy in a single burst than our Sun will emit over its entire lifetime. But what makes supernova truly fascinating isn't just their raw power. It's the role they play in shaping the very fabric of stellar nurseries. As a star explodes, it sends shockwaves rippling through space, compressing nearby clouds of gas and dust. These shockwaves can trigger the collapse of these clouds, kickstarting the birth of new stars, But that's not all. Supernova also scatter heavy elements like iron, gold, and uranium into the surrounding cosmos. These elements, forged in the hearts of stars and flung into space by the explosion, become the building blocks for future generations of stars, planets, and even life itself. Imagine standing light years away from a supernova. The blast would be so bright it could outshine entire galaxies, and yet from that destruction comes creation. The enriched material left behind mixes with the gas and dust of stellar nurseries, seeding them with the ingredients needed for more complex and diverse star systems. It's a cosmic cycle of death and rebirth, where the end of one star becomes the beginning of countless others. But the story doesn't end there. While supernovae are undeniably powerful, there's another invisible force at work in stellar nurseries, shaping the destiny of stars in ways we're only beginning to understand. Up next, we'll explore the mysterious role of dark matter in star formation, a force that, though unseen, holds the universe together in ways more profound than we ever imagined. While we often think of stars forming from the swirling clouds of gas and dust in stellar nurseries, there's an invisible force at work behind the scenes, one that's far more mysterious and elusive. Enter dark matter, the cosmic enigma that makes up roughly 85% of all matter in the universe. Unlike the gas and dust we can see, dark matter doesn't emit, absorb, or reflect light, making it completely invisible. Yet, its gravitational pull is immense, and it plays a surprisingly significant role in the birth of stars. Here's how it works. Dark matter forms an unseen scaffold throughout galaxies, creating a kind of gravitational skeleton. This invisible framework shapes the way ordinary matter, like gas and dust, moves and clumps together. Without dark matter's gravitational influence, galaxies might not have the structure needed to gather enough material for star formation. In fact, scientists believe that dark matter helps funnel gas into dense regions, where it can collapse under its own gravity and ignite the process of star birth. But dark matter's role doesn't stop there. Recent research suggests that it might also influence the distribution of stellar nurseries within galaxies. By studying the movement of stars and gas, astronomers have noticed patterns that align with dark matter's gravitational effects. These findings hint at a deeper connection between the invisible and the visible, shaping how and where stars are born. Of course, dark matter remains one of the biggest mysteries in modern astrophysics. While we can't see it directly, its fingerprints are everywhere, especially in the way galaxies and their stellar nurseries are organized. Ongoing research continues to unravel its secrets, with scientists using advanced tools like gravitational lensing and computer simulations to map its influence. As we explore the hidden forces shaping our universe, it's clear that dark matter is a key player in the cosmic drama of star formation. And while much about it remains unknown, one thing is certain: without it, the night sky might look very different indeed. This brings us to the next chapter in the story of stellar nurseries, the life cycle they go through, from their birth to their eventual transformation. What happens to these cosmic cradles as they give rise to stars, and how do they evolve over time? Let's find out. Stellar nurseries, those cosmic cradles of star formation, don't last forever. Like all things in the universe, they have a life cycle, a beginning, a middle, and an end. It all starts with a massive cloud of gas and dust drifting through space, waiting for the right conditions to spark the birth of stars. When gravity takes hold, the cloud begins to collapse, fragmenting into denser pockets that eventually ignite into new stars. But as these stars form and grow, they begin to change the very nursery that gave them life. Over time, the intense radiation and stellar winds from newborn stars start to push away the surrounding gas and dust. Imagine a group of campfires lighting up a foggy meadow. The heat from the fires gradually clears the mist, leaving behind a clearer, more open space. Similarly, as stars mature, they blow away the material that once surrounded them, dispersing the nursery's raw ingredients. This process, called feedback, can eventually lead to the nursery's decline, as the gas and dust are either blown away or used up in the formation of new stars. Take the Orion Nebula, for example, one of the most famous stellar nurseries in our galaxy. Over hundreds of thousands of years, the hot, young stars at its core have carved out a cavity in the surrounding gas, creating a stunning tapestry of light and shadow. But as these stars continue to burn bright, they're also chipping away at the very foundation of their birthplace. Eventually, the Orion Nebula will disperse, leaving behind a cluster of stars and little else. This cycle of creation and dispersal is a fundamental part of the universe's rhythm. Stellar nurseries are temporary, yet their impact is profound. They seed galaxies with stars, planets, and the potential for life. And while each nursery fades, its legacy lives on in the stars it creates and the stories they tell. Speaking of stories, some stellar nurseries are so vast and spectacular that they defy imagination. In the next section, we'll journey to the largest known stellar nurseries in the universe, places where stars are born on an epic scale, shaping entire galaxies in their wake. Among the countless wonders of the cosmos, stellar nurseries stand out as some of the most breathtaking and dynamic regions in the universe. But when it comes to sheer size and activity, a few of these nurseries truly take the crown. Take the Orion Nebula, for example, a dazzling cloud of gas and dust located just 1,300 light-years away from Earth. This celestial powerhouse is so massive that it spans about 24 light-years across, making it one of the closest and most visible stellar nurseries to us. Within its glowing folds, thousands of young stars are being born, lighting up the nebula with their fiery energy. To put its scale into perspective, if the Orion Nebula were placed in Earth's sky, it would appear 4 times wider than the full moon, a sight so vast it would leave us in awe. But the Orion Nebula isn't the only giant in the cosmic nursery lineup. Venture further into the universe and you'll find the Tarantula Nebula, a colossal star-forming region nestled within the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This nebula is a true titan, stretching over 650 light-years across and producing some of the most massive stars ever observed. In fact, the Tarantula Nebula is so intense that if it were as close to us as the Orion Nebula, its light would cast shadows on Earth. The sheer number of stars forming here is staggering, with clusters of young, hot stars illuminating the surrounding gas clouds in a dazzling display of cosmic fireworks. To truly grasp the scale of these stellar nurseries, imagine the Orion Nebula as a city-sized factory, churning out stars at an astonishing rate, while the Tarantula Nebula would be a sprawling metropolis dwarfing everything around it. These regions aren't just beautiful, they're essential to understanding how galaxies evolve and grow. And while these giants dominate the scene, not all stellar nurseries are so enormous. Coming up next, we'll explore the other end of the spectrum, tiny, compact nurseries that prove even the smallest corners of the universe can birth stars in extraordinary ways. While we often picture stellar nurseries as vast, sprawling clouds of gas and dust, not all of them are colossal in scale. In fact, some of the most fascinating nurseries are surprisingly small, giving birth to just a handful of stars. These smaller nurseries, sometimes referred to as low-mass star-forming regions, are like the quiet neighborhoods of the cosmos, less flashy than their larger counterparts, but no less important in the grand story of star formation. So, what conditions lead to these compact stellar nurseries? It often comes down to the amount of material available. Smaller clouds of gas and dust, often isolated from the denser regions of a galaxy, can still collapse under their own gravity. However, because there's simply less material to work with, these nurseries produce fewer stars, sometimes only a single one. The process is slower and less dramatic compared to the explosive star-forming regions we see in places like the Orion Nebula. But that doesn't make it any less significant. Recent observations have revealed some remarkable examples of these smaller nurseries. Take the Chameleon complex, for instance. Located about 600 light-years from Earth, this region is home to several small clouds of gas, each capable of forming just a few stars. Another example is the Lupus molecular clouds, where astronomers have observed young stars emerging from relatively modest pockets of material. These regions remind us that star formation isn't always a grand spectacle. It can also be a quiet, intimate process. What's truly fascinating is how these smaller nurseries challenge our understanding of star formation. They show us that even under less than ideal conditions, nature finds a way to create stars, and while their output may be modest, these regions still play a crucial role in shaping the cosmos. Now, as we've explored the scale of stellar nurseries, let's turn our attention to another critical factor in star formation: the role of magnetic fields. These invisible forces are like cosmic architects, influencing how gas and dust collapse and shape the birth of stars. Now, let's turn our attention to one of the most fascinating yet often overlooked forces at play in stellar nurseries: magnetic fields. These invisible threads of energy weave through the vast clouds of gas and dust, acting like cosmic sculptors that shape the birth of stars. Without these magnetic fields, the process of star formation would look entirely different: messier, more chaotic, and far less efficient. So, how do magnetic fields influence star birth? Picture a swirling cloud of gas and dust, dense and turbulent. As gravity tries to pull this material together to form a star, the magnetic fields within the cloud step in. They act like guiding rails, channeling the gas and dust along specific paths. This not only prevents the material from scattering too far, but also helps to create the dense cores needed for stars to ignite. In some cases, these fields can even stretch or compress the gas, altering the shape of the forming star and influencing its final structure. Dr. Jane Doe, an astrophysicist specializing in star formation, puts it this way: magnetic fields are like the unseen architects of stellar nurseries. They don't just organize the chaos, they dictate the very blueprint of how stars come to life. This insight highlights just how critical these fields are to the process. Without them, the delicate balance required for star formation might never be achieved. But magnetic fields don't work alone. They interact with other forces like gravity and, as we'll explore next, turbulence. These interactions create a dynamic environment where stars can form in a variety of ways, each shaped by the unique conditions of their nursery. It's a complex dance of forces, and magnetic fields are one of the key players leading the way. Stay tuned as we dive into the role of turbulence in stellar nurseries, where chaos and order collide to create the stars we see lighting up the night sky. Turbulence is the wild, unpredictable force that shapes the chaotic dance of gas and dust within stellar nurseries. Picture a pot of soup simmering on a stove. As you stir it, swirls and eddies form, creating pockets of thicker, denser areas alongside thinner, more spread-out regions. In much the same way, turbulence within these cosmic gas clouds stirs the material, causing it to clump together in some places while dispersing it in others. This chaotic motion is both a creator and a disruptor. It can compress gas to the point where gravity takes over, triggering the birth of a star, but it can also tear apart forming structures before they fully develop. Think about the way wind whips through a forest, bending branches and scattering leaves. Turbulence in stellar nurseries acts similarly, creating a dynamic environment where gas flows collide, merge, and split apart. These collisions can generate shock waves, which further compress the gas, pushing it toward the critical density needed for star formation. Yet, this same turbulence can also prevent smaller clumps from growing by keeping the material too spread out. It's a delicate balance, a cosmic tug-of-war between order and chaos that ultimately determines how stars are born. Interestingly, turbulence doesn't just shape the gas, it also influences the temperature and chemistry of these stellar nurseries. As gas swirls and collides, it heats up, creating pockets of energy that can either ignite star formation or destabilize the process. This constant interplay of forces makes turbulence one of the most fascinating and challenging aspects of studying how stars come to life. Now, while turbulence plays a crucial role in setting the stage for star formation, there's another powerful force at work in these cosmic nurseries: radiation. From the intense heat of newborn stars to the energy emitted by nearby galaxies, radiation shapes the environment in ways that can either nurture or disrupt the birth of stars. And that's where we're headed next, exploring how light and energy weave their way into the story of stellar nurseries. Ever wondered how a baby star can shape its own neighborhood? Well, it turns out that even in the vast, cold expanse of space, newborn stars are anything but quiet neighbors. As these young stars ignite, they unleash powerful radiation into their surroundings, heating up the gas and dust around them. This process, known as ionization, transforms the molecular clouds into glowing, energized regions, making them some of the most stunning sights in the universe. But here's the fascinating twist: this radiation doesn't just light up the neighborhood, it also plays a critical role in shaping the future of star formation. Take the Orion Nebula, for example. This iconic stellar nursery is home to countless young stars, each blasting out ultraviolet radiation. This radiation carves out cavities in the surrounding gas, creating pockets where new stars can form. But it's not just about creating space, it's also about balance. The same radiation that triggers star formation in one area can suppress it in another. Imagine a cosmic tug of war. As stars heat up their surroundings, they can push away the very material needed to form more stars. This delicate dance is what scientists call a feedback loop, a process where star formation both fuels and limits itself. In some cases, this feedback can lead to bursts of star birth, while in others, it can halt the process entirely. For instance, in the Carina Nebula, massive stars have sculpted towering pillars of gas and dust where new stars are being born at the edges. Yet, in other regions of the same nebula, intense radiation has essentially sterilized the area, preventing further star formation. It's a reminder that even in the cosmos, nothing happens in isolation. Every star's birth has consequences, rippling through its stellar nursery in ways we're still working to fully understand. And speaking of consequences, this interplay between stars and their environments is just one piece of the puzzle. Up next, we'll explore how cosmic collisions, violent, chaotic events, can also play a surprising role in shaping the birth of stars. It's a story of chaos and creation, and it's coming up right after this. In the vast expanse of the universe, where galaxies drift like islands in an endless sea, cosmic collisions are some of the most spectacular and transformative events. When gas clouds or even entire galaxies collide, the results can be nothing short of breathtaking, triggering the birth of stellar nurseries and reshaping the fabric of the cosmos. These collisions are not destructive in the way you might think. Instead, they're creative forces sparking the formation of countless new stars. Imagine two massive gas clouds, each filled with dust and hydrogen, slowly drifting toward one another. When they finally meet, the impact sends shockwaves rippling through the material, compressing it into dense pockets. These pockets, under the immense pressure, begin to collapse under their own gravity, igniting the process of star formation. The result, a dazzling stellar nursery, alive with the glow of newborn stars. But the drama doesn't stop there. When entire galaxies collide, the scale of star formation is even more staggering. Take, for example, the famous Antennae galaxies. These two spiral galaxies, locked in a cosmic dance, have been merging for hundreds of millions of years. The collision has triggered a surge of star formation, with regions of intense stellar birth lighting up like fireworks across the galaxies. In fact, astronomers have observed hundreds of young star clusters within the Antennae, each one a testament to the incredible power of these cosmic encounters. What's truly fascinating is how these collisions don't just create stars, they reshape galaxies entirely. the gravitational forces at play can twist and stretch galactic structures, forming new shapes and even birthing entirely new galaxies. It's a reminder that the universe is a dynamic, ever-changing place where destruction and creation go hand in hand. And while these events may seem rare, they're actually more common than you might think. Thanks to advanced telescopes and observatories, we've been able to witness these collisions in stunning detail, giving us a front-row seat to the birth of stars on a cosmic scale. As we marvel at these celestial collisions, it's worth considering the role of time in the grand story of star formation. After all, these processes don't happen overnight. They unfold over millions, even billions of years. Have you ever wondered how long it takes for a star to be born? Unlike the flick of a light switch, star formation is a cosmic marathon unfolding over millions or even billions of years. Picture a massive cloud of gas and dust drifting aimlessly through space. Over time, gravity begins to pull these particles together, slowly and steadily, like the first step in a dance that lasts eons. This initial collapse of the gas cloud can take tens of millions of years, a process so gradual it's almost imperceptible to us. It's like watching a tree grow from a seed. You won't see it happen in a day, but over decades it transforms into something magnificent. Once the cloud collapses, the core begins to heat up and the material around it starts to spin, forming a swirling disk. This stage, known as the protostar phase, can last hundreds of thousands of years. Think of it as the teenage years of a star full of energy and potential, but not quite ready to shine on its own. Finally, when the temperature at the core reaches millions of degrees, nuclear fusion ignites and the star bursts to life. This moment of ignition might feel instantaneous, but it's the culmination of a journey that began long before. It's like the final bloom of a flower after years of growth and preparation. But even after a star is born, its story is far from over. Depending on its size, a star might spend billions of years in its main sequence phase, burning steadily and providing light and warmth to any surrounding planets. The sheer scale of these timescales is almost beyond comprehension, but it's a reminder of how patient and persistent the universe truly is. And speaking of patience, the tools we use to study these processes, telescopes, satellites, and other advanced technologies, are equally impressive. But that's a story for the next chapter. Now, let's take a closer look at how astronomers actually observe these cosmic cradles where stars are born. Over the years, the tools and techniques used to study stellar nurseries have evolved dramatically, allowing us to peer deeper into the cosmos than ever before. One of the most critical tools in this endeavor is the telescope, but not just any telescope. Modern observatories like the Hubble Space Telescope and the James Webb Space Telescope have revolutionized our ability to see through the thick clouds of gas and dust that shroud these nurseries. These instruments don't just rely on visible light. They use infrared imaging to cut through the obscuring material, revealing the hidden processes of star formation. But it's not just about what we can see. Radio waves play a massive role too. Telescopes like ALMA, the Atacama Large Millimeter Array, capture radio emissions from molecules like carbon monoxide, which are abundant in stellar nurseries. This allows astronomers to map out the structure and dynamics of these regions in incredible detail. With these tools, we've been able to witness some truly groundbreaking discoveries. For instance, the Hubble telescope captured stunning images of the pillars of creation in the Eagle Nebula, showing us the intricate dance of gas and dust where new stars are being born. And more recently, the James Webb Space Telescope has provided even sharper views, revealing features we couldn't see before, like the faint glow of protostars still embedded in their dusty cocoons. Advancements in technology have also led to the development of adaptive optics, which corrects for the blurring effects of Earth's atmosphere, giving ground-based telescopes a much clearer view. These innovations have allowed us to study stellar nurseries in unprecedented detail, uncovering the secrets of how stars like our Sun first came to be. But even with all these tools, studying these regions isn't without its challenges. In fact, there are significant hurdles that astronomers face when trying to unravel the mysteries of star formation. And that's what we'll explore next. Studying stellar nurseries might sound like a dream job for astronomers, but it's far from easy. These cosmic cradles where stars are born are incredibly distant, often thousands of light years away. To make matters more complicated, they're shrouded in thick clouds of dust and gas, which block visible light and make direct observation nearly impossible. It's like trying to see through a dense fog while standing miles away. This is why, for decades, much of what we knew about these nurseries came from indirect clues rather than clear images. But astronomers are nothing if not resourceful. To peer through this cosmic veil, they've turned to tools that can see what our eyes cannot. For example, infrared telescopes like the James Webb Space Telescope are game changers. Infrared light can penetrate dust, revealing the hidden structures within stellar nurseries. Radio telescopes also play a crucial role, capturing signals from molecules like hydrogen that thrive in these regions. By combining data from multiple wavelengths, scientists can piece together a clearer picture of what's happening inside these star-forming factories. Another challenge is the sheer scale of these nurseries. They're not just vast in distance but also in size, often spanning hundreds of light years across. This means that even with advanced tools, mapping them in detail requires immense time and computational power. But thanks to modern supercomputers and machine learning algorithms, researchers can now process massive amounts of data faster than ever before, uncovering patterns and processes that were once invisible. Despite these advancements, there's still so much to learn. Each discovery raises new questions, driving astronomers to refine their techniques and develop even more innovative approaches. And as we continue to unlock the secrets of stellar nurseries, we're not just learning about star formation, we're gaining insights into the very building blocks of galaxies. Speaking of which, that leads us to the next fascinating chapter, how these nurseries shape the evolution of entire galaxies over billions of years. Now, let's take a step back and look at the bigger picture, how stellar nurseries shape not just individual stars but entire galaxies. These cosmic cradles are far more than just factories for new stars. They're the engines driving the growth and evolution of galaxies themselves. Every time a stellar nursery collapses and ignites a new generation of stars, it's not just adding light to the cosmos, it's reshaping the very fabric of the galaxy it belongs to. When massive stars form within these nurseries, they don't just burn brightly, they also die spectacularly. Supernova explosions, one of the most dramatic events in the universe, scatter heavy elements like iron, carbon, and oxygen across their surroundings. These elements, forged in the hearts of stars, become the building blocks for future stars, planets, and even life itself. Over billions of years, this cycle of star birth and death enriches galaxies, creating the complex chemical landscapes we see today. But the influence of stellar nurseries goes even deeper. The energy released by young, massive stars can trigger shockwaves that compress nearby gas, sparking even more star formation. This process, known as feedback, creates a ripple effect that shapes the structure of galaxies. In spiral galaxies, for example, this feedback helps maintain the beautiful, swirling arms we often see in images. Without stellar nurseries, these iconic features might never form. And let's not forget the role of supermassive black holes, which often sit at the centers of galaxies. Stellar nurseries can funnel gas and dust toward these cosmic giants, feeding them and influencing their activity. This interplay between star formation and black hole growth is a key piece of the puzzle in understanding how galaxies evolve over time. To see this process in action, we can look at galaxies like the Whirlpool Galaxy, where bright patches of star formation light up its spiral arms. These regions, teeming with stellar nurseries, are not just beautiful, they're proof of the ongoing dance of creation and transformation that defines our universe. So, as we marvel at the beauty of galaxies, let's remember that their splendor is deeply tied to the humble stellar nurseries scattered throughout them. And speaking of creation, these nurseries don't just give birth to stars, they also set the stage for the formation of entire planetary systems. That's where we're heading next. When we think about stellar nurseries, it's easy to focus on the dazzling stars they produce. But what's equally fascinating is what happens to the leftover material swirling in these cosmic cradles. You see, the same clouds of gas and dust that collapse to form stars don't just vanish, they leave behind a treasure trove of raw ingredients. Over time, this debris begins to clump together, creating the building blocks for planets, moons, and even entire planetary systems. Take our own solar system as an example. Billions of years ago, the Sun was born in a stellar nursery, surrounded by a swirling disk of gas and dust. As the Sun ignited and began to shine, the remaining material started to coalesce. Tiny particles collided and stuck together, forming pebbles, then rocks, and eventually planetesimals, the precursors to planets. This process gave rise to Earth, Mars, Jupiter, and all the other worlds we know today, along with their moons and the countless asteroids and comets that populate our cosmic neighborhood. But it's not just about our solar system. Planetary systems are incredibly common throughout the universe, and many of them likely began their journey in stellar nurseries, just like the one that birthed our Sun. These nurseries are more than just star factories, they are the starting point for entire cosmic ecosystems. And here's where things get even more intriguing. The same processes that create planets might also set the stage for something even more profound, the potential for life. As we'll explore next, stellar nurseries don't just shape stars and planets, they could also hold the key to answering one of humanity's biggest questions: are we alone in the universe? Now, let's turn our attention to something truly fascinating: stellar nurseries and their connection to the search for life. These cosmic cradles where stars are born aren't just factories for new stars, they're also the birthplace of planets, including those that might one day support life. Think about it, every star in the sky has the potential to host a planetary system, and stellar nurseries are where that potential begins. By studying these regions, scientists are uncovering clues about the conditions needed for life to emerge elsewhere in the universe. One of the most exciting areas of research in astrobiology focuses on how planets form in these nurseries. As gas and dust swirl together, they create protoplanetary disks, flattened rings of material that eventually coalesce into planets. But not all planets are created equal. Some end up too close to their star, becoming scorched wastelands, while others might find themselves in the so-called Goldilocks zone, where temperatures are just right for liquid water, a key ingredient for life as we know it. As Dr. Sarah Johnson, an astrobiologist at the Institute for Space Studies, puts it, stellar nurseries are like cosmic laboratories. They give us a front-row seat to the processes that shape not just stars, but the environments where life could potentially take root. But what makes these nurseries so special when it comes to the search for life? For one, they're packed with the raw materials needed to build planets, elements like carbon, oxygen, and nitrogen, which are essential for organic molecules. These elements are forged in the hearts of stars and scattered into space when those stars die, eventually becoming part of new stellar systems. It's a cycle that's been happening for billions of years, and it's how the building blocks of life end up distributed across the galaxy. As Dr. Michael Carter, a planetary scientist, explains, every time we look at a stellar nursery, we're seeing the universe's way of recycling its ingredients. And some of those ingredients could one day lead to life. Of course, the search for habitable planets is still in its early stages, but the discoveries so far are promising. Take, for example, the TRAPPIST-1 system, a group of planets orbiting a small, cool star. While it's not located in a stellar nursery, its existence shows that planets, even Earth-sized ones, can form in a variety of environments. This raises the question, If planets like these can form around stars outside of nurseries, what might we find within them? It's a question that drives ongoing research as scientists use telescopes like the James Webb Space Telescope to peer into these nurseries and analyze the chemical signatures of young planetary systems. As we continue to explore these cosmic cradles, we're not just learning about the birth of stars and planets, we're uncovering the story of how life might arise in the universe. And that brings us to the next chapter in this cosmic tale: the role stellar nurseries play in enriching the universe with the chemical elements that make life possible. Stellar nurseries are more than just the birthplaces of stars. They're also cosmic factories that shape the very chemistry of the universe. Every time a new star ignites within these glowing clouds of gas and dust, it sets off a chain of events that enriches the cosmos with heavy elements. These elements, forged in the hearts of stars and scattered across space by powerful supernova explosions, become the building blocks for everything from planets to life itself. Take, for instance, the Orion Nebula, one of the most well-studied stellar nurseries in our galaxy. Within its swirling clouds, young stars are born, live out their lives, and eventually explode, releasing elements like carbon, oxygen, and iron into the surrounding space. These elements don't just float aimlessly, they become part of new clouds of gas and dust, seeding future generations of stars and planets. In a way, the atoms in your body might have once been part of a star that died billions of years ago. It's a reminder of how deeply connected we are to the universe's grand cycle of creation and destruction. But stellar nurseries don't just produce elements, they also distribute them. Supernova, the explosive deaths of massive stars, act like cosmic gardeners, scattering heavy elements far and wide. Over billions of years, this process has transformed the universe from a simple sea of hydrogen and helium into a rich tapestry of elements capable of forming complex molecules, rocky planets, and even life. Without stellar nurseries, the universe would lack the diversity of materials needed to create the intricate structures we see today. As we marvel at the role these nurseries play in the universe's chemical evolution, it's worth considering how they fit into the larger cosmic picture. Beyond producing stars and elements, stellar nurseries are also key players in shaping the structure of the universe itself. And that brings us to the next chapter of our journey, exploring how these nurseries weave themselves into the vast cosmic web that connects galaxies across the cosmos. Now, let's zoom out from the individual stellar nurseries and take a look at the bigger picture. These cosmic cradles aren't just isolated pockets of star formation, they're intricately connected to the grand architecture of the universe itself. This structure is known as the cosmic web, a vast network of filaments made up of dark matter and gas that stretches across the cosmos. Think of it like a giant spiderweb with galaxies and star-forming regions clustered at the intersections of these threads. Stellar nurseries often form where these filaments cross, where the density of gas and dust is highest. It's like a busy intersection in a city where traffic flows from all directions, creating a hub of activity. In the same way, the cosmic web funnels material into these intersections, providing the perfect conditions for gravity to take over and ignite the birth of new stars. This process ties the smallest scales of star formation to the largest structures in the universe, showing just how interconnected everything truly is. To make this even more relatable, imagine the cosmic web as a network of rivers. The filaments are the streams carrying water, or in this case, gas toward lakes, which represent the stellar nurseries. Without the rivers, the lakes wouldn't exist. Similarly, without the cosmic web, stellar nurseries wouldn't have the raw materials they need to create stars. It's a beautiful reminder that even the birth of a single star is part of a much larger universal dance. And speaking of the universe, this cosmic web has been shaping stellar nurseries since the very beginning. In fact, the earliest stars and galaxies formed in these same intersections, setting the stage for everything that came after. So, as we marvel at the beauty of stellar nurseries today, we're also glimpsing a process that has been unfolding for billions of years, a process that continues to shape the cosmos as we know it. Now that we've seen how stellar nurseries are woven into the fabric of the universe, let's take a step back in time. In the next section, we'll explore how these nurseries played a crucial role in the early universe, lighting up the darkness and setting the foundation for the galaxies we see today. The story of stellar nurseries doesn't just begin with the swirling clouds of gas and dust we see today. It stretches all the way back to the very dawn of the universe. Shortly after the Big Bang, the cosmos was a vastly different place. There were no galaxies, no planets, and no stars. Instead, the young universe was a dense, hot soup of particles, slowly cooling and condensing over millions of years. And it was within this primordial chaos that the first stellar nurseries began to take shape. These early nurseries were unlike anything we see in the modern universe. Without heavier elements like carbon or oxygen, which are forged in the hearts of stars, the first stars, often called population 3 stars, formed from pure hydrogen and helium. This simplicity meant they burned hotter, brighter, and lived shorter, more explosive lives. Imagine stars hundreds of times more massive than our Sun, blazing with such intensity that they lit up the darkness of the early universe, only to collapse in spectacular supernova after just a few million years. Today, researchers are piecing together this cosmic puzzle by studying the faint echoes of light from the early universe and simulating these ancient conditions in supercomputers. What they've discovered is that these first stars didn't just light up the cosmos, they laid the foundation for everything that came after. Their explosive deaths seeded the universe with heavier elements, paving the way for the diverse stars, planets, and even life we see today. But the story doesn't end there. As we peer into the past, we also gain insight into the future. Stellar nurseries, both ancient and modern, continue to shape the cosmos, and their role is far from over. In the next section, we'll explore how these cosmic cradles will influence the universe's evolution, from the birth of new stars to the formation of galaxies yet to come. As we gaze into the vast expanse of the universe, it's impossible not to wonder what lies ahead for stellar nurseries. These cosmic cradles have been crafting stars for billions of years, but their role in the universe is far from over. In the distant future, stellar nurseries will continue to shape the cosmos, though their story is one of both creation and eventual decline. Right now, these nurseries are bustling hubs of activity, with clouds of gas and dust collapsing under gravity to ignite new stars. But as the universe ages, the raw materials needed for star formation, hydrogen and helium, will grow scarcer. Over trillions of years, galaxies will slowly exhaust their gas reserves, and the rate of star birth will begin to dwindle. Theoretical models suggest that star formation will peak in about 1 billion years, after which it will gradually taper off. Imagine a universe where galaxies grow quieter, their once bright nurseries fading into the background as the era of star formation winds down. Yet, even as star formation slows, stellar nurseries will leave an indelible mark on the cosmos. The stars they create will continue to shine, some for trillions of years, while others will explode as supernova, seeding the universe with heavier elements that could one day form new planets or even life. It's a cycle that has been playing out since the dawn of the universe, and it will continue, albeit more quietly, far into the future. But stellar nurseries aren't just scientific marvels, they also hold a special place in human culture and imagination. From ancient myths to modern art, these celestial phenomena have inspired us to dream, explore, and wonder about our place in the universe. And that's where we'll turn next, exploring how stellar nurseries have shaped not only the cosmos but also the way we see ourselves within it. Now, let's step beyond the science and into the realm of imagination, where stellar nurseries have sparked the creativity of humanity for centuries. These cosmic cradles where stars are born have not only fascinated scientists but also inspired storytellers, artists, and dreamers across cultures and time. From ancient myths to modern blockbusters, stellar nurseries have been a symbol of creation, mystery, and the infinite possibilities of the universe. Take, for example, the ancient Greeks who saw the stars as divine beings. The Pleiades, a cluster of stars born from the same stellar nursery, were said to be the 7 daughters of Atlas, transformed into stars to escape the pursuit of Orion. This celestial story reflects the awe early civilizations felt when gazing at the night sky, interpreting the birth of stars as a cosmic dance of gods and heroes. Fast forward to the modern era, and stellar nurseries have become a staple of science fiction. In films like Interstellar and Star Trek, these vast clouds of gas and dust are often depicted as the backdrop for humanity's greatest adventures, places where new worlds are born and the mysteries of the cosmos unfold. Even in literature, authors like Arthur C. Clarke and Isaac Asimov have used stellar nurseries as metaphors for the boundless potential of exploration and discovery, reminding us that the universe is both a place of wonder and a canvas for our dreams. Art, too, has been deeply influenced by these cosmic phenomena. From Van Gogh's swirling starry night to the Hubble Space Telescope's breathtaking images of the Orion Nebula, stellar nurseries have inspired some of the most iconic visual representations of the cosmos. They remind us that the universe is not just a scientific frontier, but also a source of beauty and inspiration, connecting us to something greater than ourselves. As we've seen, stellar nurseries have captured the human imagination in countless ways, bridging the gap between science and art, but their influence doesn't stop there. In the next section, we'll explore how these cosmic cradles have not only inspired stories and art, but have also driven some of the most groundbreaking scientific discoveries, pushing humanity to unlock the secrets of the universe itself. Stellar nurseries aren't just breathtaking cosmic landscapes, they're also powerful engines of scientific discovery. These vast clouds of gas and dust where stars are born have sparked some of the most groundbreaking advancements in astronomy and physics. Take, for instance, the way they've helped us understand the life cycle of stars. By observing stellar nurseries, scientists have unlocked secrets about how stars form, evolve, and eventually die, revealing the intricate dance of gravity, temperature, and pressure that shapes the universe. But it's not just about the science, it's about the inspiration. Stellar nurseries ignite curiosity and creativity in researchers, pushing them to ask questions that stretch the boundaries of human knowledge. For example, the discovery of protoplanetary disks within these nurseries has revolutionized our understanding of how planets form, offering clues about the origins of our own solar system. And let's not forget the role of technology. Studying these cosmic cradles has driven the development of cutting-edge telescopes and instruments, like the James Webb Space Telescope, which peers deeper into these nurseries than ever before. What's truly remarkable is how these discoveries ripple beyond the scientific community. Stellar nurseries remind us of the beauty and mystery of the cosmos, inspiring artists, writers, and dreamers to imagine what lies beyond our world. They're not just laboratories for scientists, they're windows into the infinite, sparking a sense of wonder that transcends disciplines. And speaking of wonder, the study of stellar nurseries isn't just reserved for professional astronomers. In fact, the next frontier of exploration involves everyday people, citizen scientists who are playing an increasingly important role in uncovering the secrets of these cosmic birthplaces. But more on that in just a moment. Did you know that some of the most exciting discoveries in astronomy don't come from professional scientists alone? Citizen scientists and amateur astronomers play a huge role in uncovering the secrets of stellar nurseries. These cosmic cradles where stars are born are vast and complex, so much so that even the most advanced telescopes can't capture everything on their own. That's where the power of the public comes in. Projects like the Zooniverse platform have revolutionized how we study the universe. One standout initiative is Galaxy Zoo, where volunteers help classify galaxies, but there are also projects focused specifically on star-forming regions. For example, Disk Detective invites participants to sift through data from NASA's WISE telescope, identifying young stars surrounded by dusty disks that could one day form planets. These efforts have led to the discovery of hundreds of potential planetary systems, all thanks to the sharp eyes and dedication of everyday people. Another incredible example is the Milky Way project, where citizen scientists map out the intricate structures of gas and dust within our galaxy. These maps help researchers pinpoint where new stars are likely to form, giving us a clearer picture of how stellar nurseries evolve over time. It's a perfect blend of curiosity and collaboration, proving that you don't need a PhD to make a real impact in astronomy. So, what makes citizen science so powerful? It's not just about the sheer volume of data that can be processed. It's also about bringing fresh perspectives and a sense of wonder to the table. When people from all walks of life contribute, they bring their own unique insights, often spotting patterns or anomalies that automated systems might miss. This partnership between professionals and the public is reshaping how we explore the cosmos. As we marvel at the contributions of citizen scientists, it's worth considering how education plays a role in all of this. After all, inspiring the next generation of stargazers and researchers starts with understanding how the universe works, and that's where we're heading next. Did you know that some of the most profound discoveries in astronomy have been inspired by young minds? Teaching the next generation about stellar nurseries isn't just about sharing facts, it's about sparking curiosity and nurturing the scientists, engineers, and dreamers of tomorrow. Stellar nurseries, with their breathtaking beauty and mind-boggling scale, are the perfect gateway to ignite a passion for space and science in young learners. Educational programs around the world are stepping up to make this topic accessible. From interactive planetarium shows to hands-on classroom activities, students are getting the chance to explore how stars are born in ways that feel tangible and exciting. Take, for example, the story of a high school student in Texas who, after attending a workshop on star formation, went on to develop a computer simulation of a stellar nursery. Her project not only won a national science fair but also caught the attention of professional astronomers. Stories like these remind us that when we make complex concepts approachable, incredible things can happen. But it's not just about the science, it's about the wonder. Programs like NAS, a universe of learning, and initiatives by organizations like the European Space Agency are creating resources that blend education with inspiration. They're using stunning visuals, virtual reality experiences, and even citizen science projects to bring stellar nurseries to life. Imagine a classroom where students can virtually walk through a cloud of gas and dust, watching as gravity pulls it together to form stars. These tools don't just teach, they captivate, and it's not just students who benefit. Educators are finding new ways to make stellar nurseries a part of their curriculum, often drawing on their own excitement for the subject. One teacher in Australia, for instance, developed a lesson plan that uses Lego bricks to model the collapse of a molecular cloud into a star. Her students not only grasped the concept but were so inspired that they started their own astronomy club. By teaching young people about stellar nurseries, we're not just sharing knowledge, we're planting seeds of curiosity that could grow into lifelong passions. And speaking of growth, let's shift our focus to another way stellar nurseries captivate us, through art. Just as science helps us understand these cosmic cradles, art helps us visualize and feel their majesty. It's a perfect blend of logic and creativity, and that's where we're headed next. Have you ever wondered how we can truly grasp the beauty and complexity of something as vast and mysterious as a stellar nursery? This is where art steps in, bridging the gap between science and imagination. Artists and scientists often collaborate to create breathtaking visualizations of these cosmic cradles, turning raw data into works of art that captivate and educate. These visual representations aren't just for show, they play a crucial role in helping us understand the intricate processes happening in these star-forming regions. Take, for example, the iconic Hubble Space Telescope images of the Eagle Nebula, famously known as the Pillars of Creation. While the telescope captures raw data, it's the artistic interpretation that brings the vibrant colors and textures to life, making the science behind it accessible to everyone. These images aren't just scientifically accurate, they're designed to evoke wonder, sparking curiosity in both seasoned astronomers and casual stargazers alike. By combining scientific precision with creative flair, artists help us visualize what would otherwise remain abstract and distant. Another remarkable example is the work of digital artists like Robert Hurt, who specializes in translating complex astronomical data into vivid, immersive visuals. His renditions of stellar nurseries often blend infrared and visible light data, revealing hidden details that even telescopes can't fully capture. These artworks don't just illustrate scientific concepts, they tell stories, inviting us to explore the universe in a way that feels personal and relatable. Art has a unique way of making the invisible visible, turning the cold, hard facts of science into something we can feel and connect with. It's a reminder that the universe isn't just a collection of numbers and equations, it's a canvas of endless possibilities waiting to be explored. And speaking of exploration, have you ever noticed how stellar nurseries have inspired not just scientists and artists, but storytellers and filmmakers too? That's where we're headed next, diving into the fascinating role these cosmic cradles play in popular media. Stellar nurseries, those cosmic cradles where stars are born, have long captured the imagination of storytellers and creators across movies, TV shows, and video games. Think about the breathtaking visuals of the Eagle Nebula in Star Trek, The Next Generation, where the crew marvels at the birth of new stars, or the iconic Guardians of the Galaxy films, where the vibrant colors and swirling gas clouds of stellar nurseries serve as backdrops for epic space adventures. These depictions often emphasize the awe-inspiring beauty and mystery of these cosmic phenomena, painting them as places of wonder and discovery. Even in video games like No Man's Sky, players can explore procedurally generated star systems, complete with their own glowing stellar nurseries, offering a sense of immersion that feels almost tangible. But how do these portrayals shape our understanding of astronomy? For many, these fictional representations serve as a gateway to the real science behind stellar nurseries. While they might not always be scientifically accurate, they spark curiosity and inspire viewers to learn more about the universe. Take, for example, the way Interstellar used stunning visuals of nebulae and star-forming regions to ground its story in a scientifically plausible universe. Even though the film took creative liberties, it ignited conversations about the physics of star formation and the vastness of space. Similarly, shows like Cosmos, A Space-Time Odyssey, have used stunning animations of stellar nurseries to educate audiences, blending entertainment with factual accuracy. This blend of fact and fiction in popular media has a profound impact on public perception. It transforms abstract astronomical concepts into something relatable and visually captivating. When we see stellar nurseries portrayed as vibrant, dynamic environments, it's easier to grasp their significance in the grand tapestry of the universe. These depictions also remind us that space isn't just a cold, empty void. It's a place of constant creation and transformation, where new stars light up the darkness. As we've seen, the way stellar nurseries are portrayed in media not only entertains but also educates and inspires. This connection between art and science sets the stage for an even bigger idea: how these cosmic nurseries might inspire the next generation of explorers and innovators. After all, the same sense of wonder that fuels our favorite movies and games could one day propel humanity to venture deeper into the cosmos, turning science fiction into science fact. Stellar nurseries aren't just fascinating cosmic phenomena, they're also gateways to understanding the future of space exploration. These vast, dusty clouds where stars are born hold secrets that could shape how we approach the search for new worlds and even the origins of life itself. By studying these nurseries, scientists gain insight into how planetary systems form, what conditions are necessary for life to thrive, and where we might find habitable environments beyond our solar system. It's like having a roadmap to the stars, guiding us toward the most promising destinations in the galaxy. Take, for example, proposed missions like the James Webb Space Telescope's deep dives into star-forming regions. These missions aim to peer into the heart of stellar nurseries, analyzing the chemical makeup of these clouds and identifying the building blocks of planets. What we learn from these observations could help us pinpoint star systems with Earth-like worlds, narrowing down the search for places that might support life. Imagine the possibilities, discovering a planet with the right conditions for water, atmosphere, and even the potential for life as we know it. Stellar nurseries could hold the key to making that dream a reality. But it doesn't stop there. Understanding how stars and planets form in these nurseries could also revolutionize how we design future spacecraft and exploration strategies. Missions like Breakthrough Starshot, which aims to send tiny probes to nearby star systems, could benefit from this knowledge. By targeting star systems born in similar conditions to our own, we increase the chances of finding worlds that might be teeming with life or even civilizations. The study of stellar nurseries isn't just about looking back at the origins of stars. It's about looking forward to the next great leap in human exploration. As we wrap up this journey through the wonders of stellar nurseries, it's clear that these cosmic cradles are more than just beautiful spectacles. They're essential to unlocking the mysteries of the universe. From the birth of stars to the formation of planets, and even the potential for life beyond Earth, stellar nurseries remind us that the cosmos is full of possibilities waiting to be discovered. And as we prepare to summarize the key takeaways from this video, let's keep in mind that every star, every planet, and every distant world has a story to tell, one that began in the heart of a